All right, let's talk about solving inequalities. Solving inequalities is very similar to solving equations with one exception. If you multiply or divide both sides of an inequality by a negative number, you must change the sign of the inequality. Let's do some examples. So -3 is less than 10. If I multiply both sides by -1, we get 3 over here and -10 over here. So we must change the sign from a less than to a greater than. 15 is greater than -17. If we multiply both sides by -1, we get -15 over here and +17 over here. So it's easy to see that we must change the sign to a less than. 3 is less than 5. If we multiply both sides by, let's try a different number, -2, we get -6 over here, -10 there, and you can see that -6 is greater than -10. -4 is greater than -7. If we multiply both sides by -1, we get 4 here and +7 here. And you can see that the sign of the inequality must change. All right, so multiplying or dividing both sides by a negative number. Now you can add or subtract a number to both sides, and that will not change the sign of the inequality. All right, so if we were to add the same number to both sides, you can see that the sign of the inequality stays the same. And if we subtract the same number from both sides, you can see that the sign of the inequality stays the same. All right, let's solve some inequalities now. And if you want, you could try this one on your own. All right, so just like solving a linear equation in one variable, we want to isolate the x. So we'll subtract 3 from both sides. And you can add or subtract without changing the sign of the inequality. So I get -2x is less than -10. And now I have to divide both sides by -2. So I'm not just going to write that underneath there, because dividing both sides by negative will change the sign of the inequality. So I'll write that on a separate line just so I don't get mixed up. So it changes from a less than to a greater than. We get x is greater than 5. And in contrast to a linear equation in one variable that just has one solution, the solution of this inequality in one variable is infinite. So we can graph the solution set. So this is one dimensional. We just have an x, so we can graph the solution set on a number line in one dimension. We put our boundary here at 5. And now we have 2 regions to test, because our solution set will either be all of the numbers on this side or all of the numbers on this side of our boundary value. Let me write that down for you. All right, so to test our two regions, you can choose any number in this region, like 0. Is 0 greater than 5? That's false. And we can test another number over here. Is 10 greater than 5? That's true. So if any number on this side is true, then every number on this side is true. So we can shade that. And this is a strict inequality, meaning x is greater than 5, not greater than or equal to 5. So 5 is not included in our solution set. And you can either use an open circle or a curved parentheses. And then if you want to write the solution set in interval notation, you would write x as an element of the set from 5 to infinity. And infinity is a concept, not a particular number, so it always gets a curly bracket. All right, let's try another one. All right, and if you're feeling ready, you can hit the pause button and do this one on your own. All right, so just like solving an equation, we want to isolate x on one side of the inequality and everything else on the other. I like to start with the x's. So we have x on both sides, so I can subtract 2x from both sides. And because I'm adding and subtracting, that does not change the sign of the inequality. So 5x minus 2x is 3x. And then I can add 6 to both sides. And divide both sides by positive 3. And since 3 is positive, that does not change the sign of the inequality. All right, now let's graph the solution set and write the answer in interval notation. So 8 is my boundary value. I only have one boundary value in this one-dimensional solution. So I have two regions to test. Pick any number in this region, like 6. Is 6 greater than 8? No. Pick any number in this region, like 11. Is 11 greater than 8? That's a true statement. So this is the solution set. It's a strict inequality, so you can use an open circle or a curly bracket. And then writing this in interval notation, x is an element of the set from 8 to infinity. And they both have curly brackets because the solution set does not include 8, and infinity is not a particular number. Let's do another one. All right, now I'd recommend hitting the pause button and trying this one on your own. Negative 6x minus 15 is greater than or equal to negative 2x plus 13. So we can add 2x to both sides. Remember, adding and subtracting does not change the sign of the inequality. So we have negative 4x minus 15 is greater than or equal to 13. Then we can add 15 to both sides. Negative 4x is greater than or equal to 28. And then divide both sides by negative 4. And since 4 is negative, that will change the sign of the inequality. So I like to be careful here and rewrite that step. So we have x is less than or equal to negative 7. All right, now let's graph the solution set and write the answer in interval notation. So my boundary value is at negative 7. So we have one boundary value. That means we have 2 regions to check. So I can plug in a number from either side. Now it's important to test it with the original equation because it's easy to make a mistake when you're solving it. So if you made a mistake here and then test, you might get the wrong answer. So let's check it with the original equation. All right, so I plug negative 10 into the original equation. The original inequality. And we get the statement 45 greater than or equal to 33, which is true. And just to be safe, we test both sides. Put 0 in to the original inequality. And we get negative 15 greater than or equal to 13, which is false. So that means this region is our solution set. And because it's a less than or equal to, you can either use the closed circle or the square bracket. And that points in the direction of the solution set. And since this is the negative direction, it goes to negative infinity. So our interval notation is x is an element of the set from negative infinity to negative 7, and we use the square bracket to indicate that negative 7 is included in our solution set. Let's do another one. All right, now we're going to solve some non-linear inequalities. And before we do that, we need to review the meaning of the word union and the word intersection. So union means or, intersection means and the symbol for union is this symbol, and the symbol for intersection is this symbol. All right, so if you're meeting a friend downtown and they tell you that they're either on 16th Street or on Mission Street, that means they could be anywhere on 16th Street or anywhere on Mission Street. If they tell you they're at the intersection of 16th and Mission, they're only on the parts that overlap because they have to be on 16th and on Mission Street at the same time. So that's what intersection means. All right, let's do a problem. All right, so let's contrast. When you solve a linear inequality, you isolate x, which is just like when you're solving a linear equation, you isolate x. When you're solving a non-linear inequality, you do it like you solve a non-linear equation, you're going to get 0 on one side, and you're going to factor the other side. So this one's basically solved for us. The only work we need to do now is to graph the solution set and write it in interval notation. All right, the reason we factored this is so that we can know our boundary values. The boundary values are the values of x that make each factor equal to 0. So if you can't do it in your head, that's totally okay. Just set each factor equal to 0 and solve for x. So my boundaries are 2 and 5. And because I have 2 boundary values, I have 3 regions to test. So you just pick any number in those 3 regions and put them in the inequality. So you can pick any number in that region, like 0, plug it in as -2 times -5 greater than or equal to 0. That's a true statement. So this region is in the solution set. 4 is in this region. Plug it into the original statement. Is 2 times -1 greater than or equal to 0? This is a false statement. So these numbers are not included in the solution set. And plug in any number in this region. Put in 10. Is 8 times 5 greater than or equal to 0? That is a true statement. So this region is in the solution set. And then because it's a greater than or equal to, then the boundary values are included in the solution set. So these numbers make the inequality true, or these numbers make the inequality true. So my solution set is x is an element of the set. So this goes from -infinity, which always gets a curly bracket, to gets a square bracket. And because it's this set or this set, we use union. And then 5 to infinity. All right, let's do another. Solve this inequality. And if I would recommend hitting the pause button and try this one on your own. All right, so because this is a nonlinear inequality, we want to move everything to one side. So I'm going to subtract 8 from both sides. Remember, adding and subtracting does not change the sign of the inequality. And then we factor, so we get x minus 4 times x plus 2 less than or equal to 0. All right, now let's graph the solution set and write our answer in interval notation. So my boundary values are the values that make each factor equal to 0. So those are going to be -2 and +4. I have 2 boundary values, so it gives me 3 intervals to check. So you can plug in any number in those. And I like to just do it in my head because we don't need the particular number. We just need to know whether each factor is positive or negative. So for this one, if I plug in -5, that first factor is negative. This factor is going to be negative. Negative times a negative is positive. So that's false. So these numbers are not included in the solution set. Let's plug in 0. 0 makes that first factor negative and the second factor positive. A positive times a negative is less than 0. So these numbers are included in the solution set. Then we put in 6. If I put in 6 here, that'll be positive, and this will be positive. Positive times a positive is not less than or equal to 0, so that is a false statement. So these numbers are not included in the solution set. Because it's a less than or equal to, we use a square bracket or a closed circle. We write the solution as x is an element of the set from -2 to 4 inclusive.